KFC, also known as Kentucky Fried Chicken, is a well-known fast food restaurant around the world. KFC was founded in 1952 by Colonel Alexander. Today, there are over 600 KFC outlets across Malaysia, making it one of the largest fast food chains in the country. For our QM340 project, we took KFC located at One Segama Shopping Mall. The operating time is 10 a.m. until 10 p.m. every day. We made our observation at 2:40 p.m. until 3:40 p.m. The arrival characteristic at KFC describe how customers enter the service system. The size of the calling population is considered infinite because KFC serves the general public and there is no limit to the number of potential customers who may visit the restaurant. The pattern of arrival at the system is random and customer arrival follow a Poisson distribution with an average rate of 19 customers per hour, meaning customers arrive independently and unpredictably. In terms of arrival behavior, customers are generally patient as they are willing to wait in a line to place their orders and receive service. Next, I will explain the waiting line characteristic for KFC. First, the length of the line. At KFC, the length of the waiting line is considered unlimited. This means there is no fixed maximum number of customers allowed to queue. During peak hours such as lunch and dinner time, many customers may line up and the queue can become long depending on the number of arrivals. Next, the queue disciplines. KFC use the first in, first out queue disciplines. This means customers are served in the same order they arrive. The first customer in the line will be the first to be served. This method is fair and suitable for fast food restaurants like KFC because it helps maintain order and customer satisfaction.
Next, we move to service facility characteristics. Number of channels KFC use is single channel systems. KFC only have one counter service for customer. Secondly, KFC have multi-phase system. The customer will receive two service from two station which is ordering and pickup. Lastly, the number of waiting line in KFC is single line. In this slide, we will talk about operating characters that KFC use. Is a single server multi-phase system. This system is common in process where there is only one main queue but multiple stages of service that customer must go through. The first phase is the ordering phase, where the customer places and pay for their order. After completing this phase, the customer moves to the second phase, which is the order pickup phase, where the prepared food is collected.
So now, I will explain the queuing analysis for the ordering counter using the MM1 queuing model. First, let's look at the table solution of the system. The arrival rate lambda is 19 customer per hour. The service rate mu is 33.52 customer per hour, indicating how many customer can be served in 1 hour. And the system use one server. Next, we look at average server utilization, which is 0.57. The average number of customers in the queue, LQ, is 0.74. The average number of customers in the system, L, is 1.31. Next, we examine the waiting times. The average waiting time in the QWQ is 0.04 hours, which is approximately 2.34 minutes or 140.54 seconds. And the average time spent in the system W is 0.07 hours, which is about 4.13 minutes or 247.93 seconds. Now, let's see the ordering table if have 1 until 5 counter. If have 1 counter, average server utilization 0.57, average number in the QLQ is 0.74, average number in the system L 1.31, average time in the QWQ 0.04, and average time in the system W 0.07. If have 2 counter, Average server utilization 0.28, average number in the QLQ 0.05, average number in the system L 0.62, average time in the QWQ is 0, and average time in the system W is 0.03 hours. If we have a 3 counter, average server utilization 0.19, average number in the QLQ is 0, average number in the system L is 0.57, average time in the QWQ is 0, average time in the system W is 0.03 hours. If we have a 4 counter, average server utilization 0.14, average number in the QLQ is 0, average number in the system L 0.57, average time in the QWQ is 0, and lastly average time in the system W is 0.03 hours. If we have a 5 counter, average server utilization 0.11, average number in the QLQ is 0, average number in the system L 0.57, average time in the QWQ is 0, average time in the system W is 0.03. Now, let's look at the probability of the number of customers in the system one by one. When K equals to 0, the probability that there are no customers in the system is 0.43. When less than equal to K is 0.43. If greater than K, the probability is 0.57. When K equals to 1, the probability that there is exactly one customer in the system is 0.25. When less than equal to K is 0.68. Greater than K, the probability is 0.32. When K equals to 2, the probability of having 2 customers in the system is 0.14. When less than equal to K is 0.82, and when greater than K, the probability is 0.18. And you can see more on the table for other K, which is 3, 4, 5, and so on. Therefore, we can conclude one counter is provide the best performance because it efficiently handle customer arrival while keeping waiting times low.
Now, we move on to the second phase where customer pick up their order. The first solution table shows the arrival rate, lambda is 19, service rate, mu, 28.44, and number of surveys is 1. Here shows the average server utilization is 0.67, which indicates that the counter is busy 67% of the time. Average number in QLQ is 1.34, average number in the system L is 2.01, average time in the QWQ is 0.07, and average time in the system is W 0.11. For the second table, it shows the probability of the same parameters when additional servers are added to be 5 servers. The last table illustrates the probability of having K customers in the system. If K equals to 1, probability number in system is 0.22. Probability number in the system is less than and equal to 1 is 0.55. And probability number in the system more than 1 is 0.45. If K equals to 2, probability number in system is 0.15. Probability number in the system is less than and equal to 2 is 0.7, and probability number in system more than 2 is 0.3. The same concept applies to the subsequent values of K.
For the conclusions, is the number of servers provided adequate? The number of servers is considered adequate as the average waiting time is short and within an acceptable level. Hence, adding additional servers is unnecessary at this stage. Second, are the customers are happy with the waiting time? Customers are satisfied with the service system as the average waiting time in the queue is less than 5 minutes, which is considered short and acceptable. Through this project, we learn how to analyze waiting lines using queuing models, calculate key measures like average waiting time and queue length, and understand how system design affects service efficiency. We also practice applying theory to real-world scenarios and making recommendations to improve operations.